So this problem says to let f of x equal 5 plus 3x all squared, and f of x has one critical value at a equals blank. So the first thing that we're trying to find is the critical values, and it tells us that we only have one. In order to find the critical value, we need to first take the derivative. So let's find the derivative. Because this function has an outside function and an inside function, let's use the chain rule. So the power rule for the outside function will bring the 2 down, leave the inside the same. Subtract 1 from the exponent to make just that a 1, and then times the derivative of the inside. The derivative of 5 is 0, the derivative of 3x is 3. So the derivative we can bring the 3 to the front to make this 6 times 5 plus 3x, and then distribute the 6 to make 30 plus 18x. So from here, now that we've found the derivative, to find the critical value, we set the derivative equal to 0 and solve for x. So subtracting 30 on both sides gives us negative 30 is equal to 18x, and then divide by 18 on both sides, which gives us x is equal to, let me grab my calculator, 30 divided by 18 is 1.6 repeating, so let's just leave it as a fraction. We could write it as 30 over 18, but because they're both even, let's divide by 2 on top and bottom, which makes negative 15 over 9. But now we have a factor of 3 on top and bottom, so let's divide by 3 and get negative 5 over 3. So that would be our critical value, is a is equal to negative 5 over 3. That is, oops, not 8, 3. So that's the critical value where the first derivative is set equal to 0. So now the next part of the question says for x is less than a, f of x is, and the options for these blanks are either increasing or decreasing. So to figure out whether a function is increasing or decreasing, we need to know whether the derivative is positive or negative. So let's draw a little number line and label our critical point. So we know that on either side of our critical point that the function is either increasing or decreasing depending on whether the derivative is positive or negative. So let's figure out what happens to the derivative on either side of these critical points, or this critical point I should say. And to do that, let's use a test point, something less than 5 over 3. 5 over 3 is just a little bit less than 1, or a little bit bigger than 1, so let's make this negative 2. And then over here, let's use a test point of 0, because something bigger than something negative could be 0. So plugging in to our derivative, f prime of 2, negative 2, is if we plug in negative 2 into our derivative, we get 30 plus 18 times negative 2, and that would be 30 minus 36, which is a negative 6. So our derivative is negative to the left side of our critical point. So when x is less than a, the function has a negative derivative, which means that the function is decreasing. Let's also use our test point of 0. So our derivative at 0, we would plug in 30 plus 18 times 0, which is 30 plus 0, which is just a positive 30. So our derivative is positive. Where our derivative is positive, our function is increasing. So here we go. Our critical value, when x is less than a, our function is decreasing because the derivative is negative. And for x is greater than a, our function is increasing because the derivative is positive. So I hope this video was helpful. If it was, please subscribe to my channel for more homework help questions and share with anyone who you think might find these videos useful. Thanks.